So we'll see the next concept, questions related to this leak question. So this is simple concept only. So leak we can consider as a pipe which is emptying a tank and we can proceed. But this is an important concept because repeatedly they ask these questions in the exam. So we'll see the working of this leak concept. Say suppose there is a tank and a pipe A fills the tank. So usual time taken by this pipe to fill the tank is 10 hours. So there is only one pipe which is filling this tank. So but there is a leak in the tank. So when there is a leak, so what will happen? Simultaneously water will be draining off. Slowly water will be draining off, and this pipe A will take more time than this 10 hours to fill this tank. Say because of this leak it is taking 12 hours to fill the tank. So it is taking more time than this 10 hours to fill this tank, and for example we have taken as 12 hours. Because of this leak, this pipe A is taking 12 hours to fill this tank. So once the tank is filled, after this 12 hours, so the tap is closed, the pipe A is closed. And now what will happen? The leak slowly drains off all the water. Now the question what they will ask is, what is time taken by the leak to empty the whole tank? So here what is the concept? The leak is draining off. It is like a pipe emptying a tank. Now the question is, what is time taken by this emptying pipe to empty the whole tank? So here leak is considered as an outlet pipe. So it is nothing like a leak is nothing, it's the same as a pipe emptying a tank. It is equal to an outlet pipe which is emptying the water in the tank. So inlet pipe fills water, outlet pipe drains out the water. So here leak is considered as outlet pipe, and we can work out this question is also in the same pattern. So I'll show you the working here. So now what is the usual time taken by this pipe A to fill the tank? So it is 10. Now time taken by the leak is not known, so we'll do L. And now what is total time? 12 hours. So total time is 12 hours. So when total is given and one tap's efficiency is given, if you are asked to find another tap, so I have told you, you can write AB by A minus B and work out. So this is equal to 12. And now for working this, so time taken by the leak will be more, so always take emptying minus filling. So after simplifying this, so 12 minus 10 it is 2L. Now L. So what is time taken by the leak to empty the whole tank? It is 12 into 10 by 2. So whenever they ask for this question, what is time taken by the leak to empty the whole tank, instead of doing all this, so you can consider this pipe also as a this leak as a pipe emptying a tank, and just you can write product of time taken, that is time taken by A, usual time, and now time taken by A because of this leak. So product of this two time taken by the difference. So as they ask this leak questions repeatedly, so it is nothing different, like it is the same as the outlet pipe. So to find time taken by the leak to empty the whole tank, so just instead of doing all this, the time taken by the leak is, so product of these two timings. So these two timings are taken by pipe A only. So this is the usual time, and this is time taken by pipe A to fill the whole tank because of this leak. So product of time difference in time. So product of time in the sense time taken by A to fill usual time and time taken now. Product of 10 and 12 and difference in these two timings. So when they ask time taken by a leak to empty a whole tank, so you may get questions like this. So instead of working out all this, so find product of these two. So which is time taken by A itself, usual time, and time taken now because of the leak by difference in this timings. So now what is time taken by the leak to empty the whole tank? It is equal to 60 hours. So when they ask questions regarding to this leak, so it is nothing but a pipe which is emptying. You can follow the same pattern, and time taken by the leak is got by product of time which is given, that is usual time and time taken now by difference in this time. So now we'll see an example how to work out using this concept. So we'll see an example for concept of the leak. The question is, pipe A can fill a tank in 5 hours. Because of the leak in the tank, it takes half an hour more to fill the tank. So find time taken by the leak to empty the whole tank. So here the usual time taken by pipe A is 5 hours, and because of the leak it is taking half an hour more. So now what is time taken? So half an hour plus 5, so 5.5 hours, 5.5 hours. Now what is time taken by the leak to empty the whole tank? So using the same concept, that formula, product of time by difference in time, we can find time taken by the leak to empty the whole tank. So we'll see the working. So time taken by the leak is product of time so that is product of the usual time and time taken now by the pipe A by difference in time. So what is the usual time taken? It is 5 hours. And what is time taken now? It is half an hour more. So you can take either 5.5 or 5.5. So now time taken by the leak to empty the whole tank. So product of these two timings by difference in this timings. So it is 5 into 5.5 and difference is half an hour or 0.5. So now simplifying this, we get time taken by the leak to empty the whole tank. So as you have decimals, so multiplying and dividing by 10, both single decimal places. So multiplying the numerator and denominator by 10, so this we can eliminate the decimals. Now what is time taken? So it is 55 hours. So time taken by the leak to empty the whole tank is 55 hours. So when they ask question regarding to the leak, so leak is nothing but a pipe which is emptying a tank. So you can consider the leak as a pipe which is emptying the tank. So the same procedure, product of time by difference in time. So here product of time will be time taken, the usual time and time taken now. This product by difference in timing will give you time taken by the leak to empty the whole tank. So we'll see the next example. So the question is, a leak can empty a tank in 4 hours. As another pipe A is filling the tank, the leak takes 9 hours to empty the same tank. So find the time taken by the pipe A to fill the whole tank. So here, this is another question related to this leaks. So earlier, so they gave time taken by A to fill a tank, and because of the leak, pipe A took more time. So in this, it is the same, the converse of the concept. So base is given for the leak. Normally a leak can empty a tank, empty a whole tank in 4 hours, and simultaneously a pipe A is filling the tank. And because of pipe A is filling, the leak is taking more time, more than 4 hours, that is 9 hours to empty the same tank. Now we are asked to find time taken by A to fill the whole tank. Earlier we were asked to find time taken by the leak to empty the whole tank. So base was for filling pipe. So here base is leak. Time taken by the leak is given because of A is filling, it is taking more time. Now we are asked to find time taken by A to fill the whole tank. The same working we can use, only the concept is reversed. So we'll see the working. So the leak, the usual time is 4 hours, and because of pipe A is filling, it is taking more time, so that is 9 hours. So now we are asked to find what is time taken by A to fill the whole tank. So the same working. So to find time taken by A, so to fill the tank, the working is same, the concept only is different. So there filling was the base, leak was asked. Here, so the leak is the base, and you are asked to find time taken by A to fill the tank. So because it is filling, it is taking, the leak is taking more time to empty. So now product of time by difference in time. So recently in one exam they asked questions of this pattern. This is the same as the working as we did for the leak. So don't get panic or don't think that it is some different working. The same working here. So usual time for the leak to empty 4. So filling it is taking 9 hours. So time taken by A to fill the tank. So product of time by difference in time. So 36 by 5 hours. Or it is equal to 7 by 5 hours. Suppose if they give in hours and minutes, so convert this 1/5 of an hour also to minutes. And now what is time taken by pipe A to fill the tank? So it is 7 hours, 12 minutes. So same working, but concept only is reversed here. So time taken by A to fill the whole tank and leak base is given. So product of time by difference in time. Here product of time will be time taken by the leak and time taken by the same leak when pipe A is filling. So product is 36 by 5. Difference is 5. So it is 7 by 5 hours or 7 hours and 12 minutes. So we'll see another example. So the question is, a leak can empty a full tank in 12 minutes. If the leak is absent, 2 pipes A and B can fill the tank separately in 15 minutes and 20 minutes respectively. If the leak is active and both the pipes are open, then the tank will be filled in. So time is asked. Now this question was asked in SSC CGL Tier 1 2013. So in this question we have more than 2 taps. So leak is given. So I have already told leak is nothing but a pipe which is emptying a tank. So we have more than 2 taps. So we can use the LCM concept and work out. So leak can empty a tank in 12 minutes. So we can consider it as an outlet pipe, an emptying pipe which is emptying the tank in 12 minutes. And now there are 2 taps A and B which can fill in 15 minutes and 20 minutes. Now taking LCM for all this time taken, we can find what is time taken by the taps to fill the tank. So we'll see the working. So in this question, we have 2 pipes filling A and B and 1 leak which is emptying the tank. So we can take this leak as emptying pipe which is emptying the tank. So now more than 2 taps, we can use the LCM concept for this working. So there are 2 taps, 2 pipes A and B. And what is time taken by A to fill the tank? That is 15 minutes. And what is time taken by B to fill the tank? It is 20 minutes. And instead of another pipe, there is a leak in the tank. So this leak we'll consider as a pipe which is emptying the tank in 12 minutes. So for emptying, we'll take a minus sign. So now for more than 2 taps, so we can take LCM for time taken. So what is LCM for 15, 20 and 12? So it is 60 liters, and we'll assume that there is a tank which can hold 60 liters. So you visualize that there is a tank which can hold 60 liters, and visualizing itself will reduce your working. So there is a tank which can hold 60 liters, and if A can fill it in 15 minutes, in 1 minute, so how much water A can pour? Divide 60 by 15, so it is 4 liters. And what will be the amount of water poured by B? So it is filling in 20 minutes, so fill this 60 liters. Now divide 60 by 20, so in 1 minute, B can pour 3 liters. So this leak is emptying the tank in 12 minutes. So in 1 minute, how much water it can empty? So divide the 60 by 12. So in 1 minute, the leak can empty 5 liters. So as it is emptying, we'll take minus here. So now A is pouring 4 liters, B pours 3, and the leak empties 5 liters. So how much water will be there in the tank in 1 minute? So when all the 3 are working, both types open, and if the leak is also operating, so 7 minus 5, 2 liters. So as the leak is simultaneously emptying, we'll have only 2 liters of water in the tank in 1 minute. Now what will be time taken by all the 3 to fill? So all the 3, as they are pouring 2 liters per minute, to fill 60 liters, what will be time taken? So divide the 60 liters by 2. So per minute 2 liters to fill 60 liters. All these 3 take 30 minutes. So here the answer is option A, 30 minutes. So though we are talking about the leak, so we can consider this leak as a pipe emptying, and for more than 2 pipes, take LCM for time taken and find work done by individual pipes and find the effective work done. So 2 liters per minute to fill 60 liters, 30 minutes is the answer. So we'll see the next concept.